Hello, everybody. I'm Drew McDaniel. This is Ganesh Srinivasan. We're both senior program managers in the Windows Azure team. And during this session today, first I want to thank you for traveling all this way. I'm actually not sure if we're still in New Orleans or not in this room. But this is going to be a really exciting session, and I'll tell you why. I mean, who has ever needed to do some development or testing or check out a scenario and didn't have the machines to do that? All right, and so the first thing that comes along, we had virtualization, which is really a godsend. It was able to do a lot of things in that one box, spin them up, spin them down, save them. But as you got larger and you needed to do some scale-out environments, if you ever have any complex thing with multiple machines, it gets to be a real pain. And so as we look into this session, we're going to talk about how you can use Windows Azure, how you can use some of the existing tools. But by and large, really this gets into this infinite amount of compute and storage that you have. And when you're using it for a quick dev test environment, you need to scale things out. It's a really, really great solution. And we'll walk through how that really comes together in what we're doing today. Grab the right clicker. All right, so first off, how many of you guys were at either Mark Rusinovich's talk or the Infrastructure as a Service on SharePoint or SQL sessions? Okay. Some people, there's some of the content we're going to go through is similar content at the overview level. We'll go through it a little quick because some of it, you may have seen it before. But if I'm going too fast through any of that, feel free to pause, ask a question, and we can dig into any areas there. We'll also have some time at the end for question. As well, MSDN offers. So we've announced this week a lot of changes and expansions of what we're able to do with MSDN in Windows Azure. And we'll talk about that and how that really applies for anybody that has an MSDN subscription. Show of hands, who has an MSDN subscription and has activated it for use on Azure? All right. And how many people had it activated before this week? All right, cool. So there's definitely, and we can, there's new opportunities in the booth downstairs. We can walk you through both how to do the activation. There's a set of prizes on that. And hopefully at the end of today's session, you'll actually walk out of here with a reason why you really should do that if you ever are looking to do any kind of use of Azure. Oh, sorry. And then we'll hand off, go over to Ganesh to cover a lot of the scenarios, the hybrid, and some additional examples. So starting with Azure as an overview, there's really 6 key principles that we look at. And the first 2 are somewhat similar, both the economics of usage of the cloud and usage-based billing. So usage-based billing is really you pay for what you use. And we've just recently changed this in Windows Azure. Instead of paying on the hour basis, you actually pay on the minute basis. So if you only use a machine for a short amount of time, that can be a really dramatic impact for how you do your work, as well as it changes some of the things that you can do with Windows Azure that you might not be able to do with some of the other clouds. Automation and elasticity. As you start working with Windows Azure, as you start working with the cloud, the consistency of the cloud, all of a sudden using a lot of these automation tools. PowerShell, if you're a Windows developer or IT pro, cross-platform tools. We got a set of Node.js tools. But doing the scripting for both scale-in, deployment, getting consistent deployments of your application is a really, really key solution. And we'll talk a little bit about the PowerShell, give a few examples of PowerShell today. And we'll have more and more of those online that you can use and leverage in your work. And then the final piece, final 2, managed hybrid and always on. The hybrid solution, whether that is on-premise to the cloud, that's cloud to cloud, hybrid using both Windows and Linux. There's a lot of different variations of hybrid solutions that you may build out of with Windows Azure. And in addition, you have the always on, always available, always up, a very global footprint that gives you very high consistency, high availability of what is in Windows Azure. So Infrastructure as a Service, for those of you who are familiar with Azure about a year ago, we didn't have the notion of Infrastructure as a Service. We had a Platform as a Service. And if you're developing a new application, the Platform as a Service is a great place to be. It's still a great solution. But if you're an IT pro, some of that was somewhat difficult to approach. You really had to start in Visual Studio as the really only way to get running on Azure. If you wanted to run some of the traditional applications, it was a challenge. Today, with our Infrastructure as a Service, you have multiple ways to get started. The two most common ways that people look at and use are the management portal, which is a great HTML5-based solution that you can leverage. It gives you a lot of flexibility. It's a very nice, easy-to-use portal. But it's really kind of designed at getting started, kicking the tires, very ease of use. PowerShell goes into a little bit more depth. There's a lot of things you can do. For example, if you want to script up a machine with 16 disks right at once, you can do that in PowerShell. You can't do that in the portal. Doing things repeatedly, again, PowerShell allows you to do that. In addition to PowerShell, we have a set of tools based on Node.js that are available for Windows, Mac, or Linux. And so you can leverage those as well if you're using a different environment other than just straight Windows. And then both of these tools and all the scripting interfaces are built upon a set of common REST APIs. And so if you want to program directly against that using REST, essentially build out our portal, everything through the portal goes through those REST APIs. Those are all available for programmatic interface from multiple languages. Now, the infrastructure as a service, one of the really key things is supporting the consistent common applications. So on the Microsoft side of things, when we really started looking at this, SharePoint, SQL, Active Directory coming along with those two, those are some of the key applications that we were shooting for and we knew we had to hit and be successful in the cloud. Now, the items that you see here that are underlined, those are the ones that are available in the gallery. The other items that are not underlined are ones that have been tested and validated by the product teams in Microsoft, but are not yet in the gallery. And that's really one of the great examples or reasons why Windows Azure may give you some advantages over some other cloud providers. Microsoft has a very extensive set of tests that we use for virtualization platforms. Windows Azure has gone through all of those tests. The product teams are testing their code on Windows Azure. That's why you don't see all of the products on there, because we work with individual product teams and make sure that they have signed off on it, they have validated it, they have the recommendation and can give the right guidance to customers to use that product on Windows Azure. But with the infrastructure as a service, where we give you the hardware and you manage the operating system on up, it also adds the flexibility to bring on open source operating systems. So specifically, we've got a set of Linux operating systems. The four listed here are the ones that are in the gallery. So Ubuntu, that is provided by Canonical, OpenSUSE, and SLES, that is provided by SUSE, and CentOS, which is provided by OpenLogic. And our thinking here and our focus here is we wanted to partner with some of the folks that are the best in the business around open source. Microsoft, we invest a lot in open source, but we're not the best. We have some expertise in Windows, we have some expertise in open source, but we want to partner with some folks to really bring that open source solution in. And so you have that flexibility in the infrastructure as a service to run those versions of Linux. You can also bring your own version of Linux. If you bring your own version of Linux, we have a Windows Azure agent that you install into that. And that just does some minor things to make sure that that Linux instance runs well on Windows Azure. That agent's open sourced, but if you start from one of those in the gallery, you don't even need to worry about that. It's been validated, it's been tested by these partners, and they continue to update that. So when there's new patches, those are updated on a very frequent basis. Now, when it comes to virtual machines, really the three parts that are very important are the compute, the CPU pieces, the storage, and the networking. So the compute's a little obvious, but the storage is sometimes worth talking about a little bit. In Windows Azure, we use the VHD format, the industry open VHD standard, that allows you to move your machines very easily between on-premise and Azure. And so by using that same format, by using the same underlying hypervisor, both the hypervisor in Windows Azure and the hypervisor in 2012, it's the same fundamental hypervisor. And this allows you to move your machines up and down. There's a few limitations specifically around what you can do networking-wise, and that's because it's a multi-tenant environment. So specifically, if you're trying to do something that requires broadcast or multicast, that is one thing that he's not able to do in Azure. But otherwise, if it works on Hyper-V, it will work in Windows Azure. And then by using that format, it allows you to move data around as needed. Now, the data and the storage we'll talk about, and we'll look a little bit how that's structured. It's stored on multiple disks in the data center. This gives you a couple different things. One is it gives you very, very high reliability. So the data in Windows Azure is stored on 3 disks locally, and by default, it'll also be replicated to another location for disaster recovery. Now, typically on a dev test scenario, you probably want to disable that and just use the local redundant, and they'll give you a discount of about 30% on the overall charges. By using the Windows Azure storage, it has a massive amount of scalability. And so what it tries to do is it watches how the usage is going into the disks. And for hot disks and for hot VHDs, it will actually spread those around to actually give consistent performance. And so this is really important if you're doing performance-related testing in Azure. You really want to let the disks warm up. You want to hit it for about 45 minutes. That causes storage to do the proper spreading and load balancing of it. And so you can actually get the right metrics if you're doing a performance test. So let's switch over. Actually, I'm going to call Ganesh up here to log us in. We'll switch over and look into some of this. All right, so this is the Windows Azure portal as you come into this. A couple things to point out. First off, just recently updated is the notion of stop deallocated. We'll talk about it a little bit. If you're using Windows Azure before, or if you've seen some of the documentation, we used to tell you had to completely delete your virtual machines to stop paying for them. Now, when you stop it, it will be stopped and removed from the underlying compute. And so we'll no longer charge you for the CPU. You'll only be charged for the storage that you have on those disks. It allows you to very rapidly spin them back up without massive charges on that. Now we'll do a quick walkthrough. The easiest way to deploy a virtual machine, coming into the portal, there's a quick create that allows you to get something up and running very, very rapidly from a set of images. But the most common way to go through this, and if you're going through this the first time, is you want to use this gallery. Now, oops. I'll have you log back in. Your phone, no. I had this lead. Let's go back. Sorry about that, guys. So in the gallery, we have a lot of different images. We have our server versions, Server 2012, 2008 R2, a large variety of SQL images that are available. In fact, the SQL images are growing at such a rapid rate that we'll probably look at reorganizing the UI a bit. But you can choose between SQL Server 2008 R2, SQL Server 2012, as well as the different operating systems. So if you want to run it on Server 2008 or Server 2012, and the different versions of SQL. We also have BizTalk in here, SharePoint Trial, and then the set of Linux operating systems, OpenSUSE, SLES, Canonical, and CentOS. Now, if we select the Windows server, we'll just go through, and we'll kick off a first machine just to show you how this goes through. You select a server name. This will end up being the host name of the machine. You put in a user, and you want to use this will rename the administrator account to this user account to provide a higher level of security. Then you select the location of your virtual machine. Now, this is the DNS name that will be exposed to the internet. Ganesh will show us a little bit about some of the endpoints and when you're doing a dev test environment, how you can change that around so your machine's not exposed to the internet at all through some technology that we have available in the networking stack. In addition, I wanted to call attention to the subscription here. So if you have, should I hit the right key this time? So if you have multiple subscriptions to Windows Azure, it'll come up here and show you whether it's an MSDN benefit-based account or another subscription, whether that's a pay-as-you-go or an enterprise agreement-based subscription. This is important because we have these new capabilities in the MSDN subscriptions that's going to change the pricing that you pay, what you can deploy, and the things you can test. It'll actually give you a lot of flexibility. But you want to make sure that when you're doing that you deploy into that MSDN account versus accidentally deploying into a production account where you may be charged more for the operating system or the application. And we'll show you some more about that in just a bit. So we're going to kick this off into our production account, just for this example. Another thing worth noting, and we've talked about in some of these other sessions, is PowerShell. So by default, remote PowerShell is enabled. It's enabled through HTTPS, so it's secure in the way it's done. And you can then connect to the machine and configure it to install applications, roles, services. And in fact, we have a set of scripts that will go through and deploy an entire SharePoint high availability farm across 10 different machines using SQL Server, HA, multiple Active AD servers, and multiple SharePoint servers, all through that one script-based solution. You can take that, kick it off, and that's also a great place to start to customize it and configure it as you want and give you some ideas on what you can do through the automation of PowerShell. So as this is deploying, one of the things that's really easy and nice to work with in Windows Azure is the fact that the disks are stored in blob storage. Windows Azure Storage has storage that stores blobs, tables, and queues. But a blob store is really something that you can work with almost as a directory structure. And so you can go and browse your storage. And so if you look at this machine, I'll click into one I deployed earlier. A set of images here will show where the VHDs are located. So it's in this storage container with the specific names. And we can use a set of tools. This is a tool called Cloud Explorer that allows us to, as I said, look at this essentially like a file system. We can drill into this container and see these VMs running. You'll notice that these test VMs, this is the OS disk that's being written to right now. The data drives, these two data drives are ones that are not being actively written to. But this is all the live writes are going to those disks. By default, our data drives are provisioned with no caching, which is really the best way to start for performance purposes. The OS disk is provisioned for read-write caching, and it really is something that works very well on the operating system disk. But for your data drives, you tend to want to use no caching. It's also why when you're doing something, building out for performance purposes, you really want to put the data where you're doing a lot of I/O to on data drives and leave the operating system for the application installation. Now, let's say that we have this machine, this test VM, machine. We've got it set up how we want. We're getting ready to run our test. We want to take a quick snapshot of that. What I've done is I've built a set of tools, a set of scripts. So in here, I've got one for snapshot and one for restore. So I'll kick this script off, and then I'll show you a little bit about what it's going to be doing. Where's the snapshot? There we go. So the snapshot takes as parameters the service we want to snapshot, the virtual machine, the storage account, and then the container that we want to put the snapshot disks into. So we'll kick this off. And what that's going to go do, it's calling the PowerShell commands to interrogate the virtual machine, find out where its disks are located, and then it's connecting into Windows Azure Storage and making a copy of those disks. Now, by the nature of Windows Azure Storage, a copy operation is exceptionally fast. So let me do a refresh here. And you see this new container show up, and this has a copy of all of those disks. Windows Azure Storage only is, by the nature of the storage system, it's more like a log-based file system, if you're familiar with that. So making snapshots and copies of data is very, very fast. And then it just stores the modifications to those snapshots. And so by putting these into this other directory, we can then revert back to this current state fairly simply. So let's say if we had done some modifications, changes, ran the test. If we want to revert back, there's a simple script. Go down here. That's a restore. Takes the same set of parameters. You point it at the snapshot container, and it goes through and does the restore of the virtual machine back to its current state. We're going to let this run. It takes a little bit of time. These scripts are something that we'll be putting up in our script center so that you can leverage, you can use them. We'll also be putting these scripts up on a GitHub location so you can make modifications, you can enhance them to really get you up and running with these tools, because they really do add a ton of power to what you can do with Windows Azure. So for high availability, as I mentioned, in Windows Azure, we use a set of commodity hardware. So we have physical machines in a rack. There's actually a picture of one of the early versions of the racks in Windows Azure. As you see in here, though, we have a single power distribution unit. And as well, there's a single top-of-rack switch that's not shown on here. And so Windows Azure has the software in the data center to monitor the usage, monitor the VMs, and help out if a machine fails. And so we have a large number of these machines in the data center. And if you're deploying into this hardware, you use what's called an availability set. Now, what an availability set is it tells Windows Azure that these set of virtual machines are providing a common service. So take for SharePoint, the web front ends on the front, you'd put them into a common availability set. Your SQL servers and HA, common availability set. That then tells Windows Azure to spread those virtual machines across physical hardware so there's no single point of failure in your network. Then you may use a load balancer and setting up probes, like again for your SharePoint front ends. That then spreads the load across those machines, and Windows Azure will monitor that, and at any point in time if it detects a machine having failed, it will redirect the traffic only to that machine that is still up. In the background, Windows Azure detects that failure, whether it was a network failure, whether it was a PDU failure, and will replicate and move your machine over to another node. It'll connect up to the same Windows Azure storage in the back end, so it'll bring your machine right back up, essentially in a crash-consistent way. So we've recently changed to charge you only for what you're using on a per-minute basis. A lot of our competitors will round up to the nearest hour for your usage. And you end up paying for that amount, even if you only ran the machine for a few minutes. Now, it's a nice thing to have, and especially if you're doing dev tests, if you're just spinning up things and trying it out, it can be very useful. But it also gives you flexibility. Before, you might need to, if you have a machine, if you want to reset it to a pristine state, you would think twice before you did that, because you would be spinning up another machine. You might pay for another hour of usage. By doing it on a per-minute basis, it gives you the flexibility to easily revert to an existing state, to spin up multiple machines, and kill them as you need them, spin them up as you need them, and you're only paying for what you're using down to the minute. So it does allow some of the flexibility in how you design and use your applications, as well as save some money on just the dev test scenarios. And so in Azure, we will only charge you for that bit that you're using. In addition, this is a change to Windows Azure, and if you've used some of the other cloud providers, it may be a bit of a surprise, but you used to be charged for your machine as it was deployed, even if it was being used or not, if it was running or not. And we would keep charging you because that machine was out in using compute capacity, ready to be turned back on. Now we actually will deallocate those machines, freeing up that capacity, and then stopping the meter. So now when you're using it, you pay for what you're using it when it's running, and as soon as you stop it, we'll stop charging you down to the minute. Another very big change that's just been announced this week is changes to our MSDN usage rights. If you had MSDN, you always had Azure offerings, But it was somewhat limited. It was really the base Azure. You could use it for development. You could use it for production usage. You couldn't take your software that was part of part of an MSDN subscription and use it in Azure. So the first thing that's been changed is we've enabled the software usage rights for the server software in MSDN to be used on Azure. And so SQL Server, BizTalk, SharePoint, those servers, if it's available in your MSDN subscription, in the type of subscription you have, you can take that and use it directly in Windows Azure. In addition to that, some of the software we have in the gallery will also be charged at a lower price. And we have an example of that. We've also simplified the monetary credits. You used to have this big list of buckets of resources that you could use, and you had a certain number of hours of compute and a certain gigabytes of storage that you could use. It got very difficult to really get a good sense of what you're using. You had to pull out a calculator to really figure out what you were being charged. Now you have one set credit, $50, $100, $150 a month, depending on your MSDN subscription, that reoccurs every month. So you say you have premium, you use that up as you go to $100. If you have what's called the cap, which is the default behavior, when you hit that level, the subscription shuts down, your machine's shut down, and then you can come back and use those the next month. If you want to keep going more than that, then you can put in your credit card and be billed only for that amount over that $100 or $150, whatever that is. In addition, let me come over. We've changed the prices on the software itself. So Windows Server in a standard IaaS, if you're using it for production usage on a pay-as-you-go basis, is 9 cents an hour per core. Linux is 6 cents an hour. So now you'll see the MSDN price for Windows Server is the Linux price. Similar to what you would see if you had the MSDN subscription, you wouldn't be paying for the Windows Server on-premise when you're using it for dev test. Now you no longer pay for that in Azure. Same thing goes across the software. So you look down here, SQL Enterprise, for production usage, you're paying $2.19 per hour, now 6 cents. And so that's a massive, massive savings in what you'd be spending otherwise. But by and large, it's also a great ease of use. You don't need to bring your own software. You don't need to install it. You can just use the images that are there in the Windows Azure gallery to spin up your machines. They're patched. They're kept consistent, so they're always ready for your use. One key point, though, is a change from this offering from what we have today in the MSDN benefit. The MSDN benefit today is there's no restriction on using it for dev test only. So you can use it for dev test. You can use it for production. The new offer with these lower prices, the ability to use your software, is only for dev test purposes only. And so you have the choice to stay in your existing offer that can be used for production, or to move to the new offer. You have the choice to stay in the existing offer for up to 1 year. And let me just show you real quick what this looks like if you want to change. So if you're in the portal, I've got my MSDN subscription. If you flip over to View My Bill, log in here. You now have the opportunity, and it will show up on your MSDN subscription, to either automatically get moved over by August 1st, or if you want to move to the new subscription, the new offer type that gives you that 6 cents an hour usage per core and the 50, 100, 150, you can come in here, click this button here, and you'll be taken to that new subscription within a week. You'll get a notification when you've been moved over to that new subscription type. On the other hand, if you say, hey, I was using the old thing, I actually got production workloads, it's not dev test only, I really need to stay on that existing subscription to stay in compliance, you can come in here and select this option, and we will give you until the end, until August 1st, 2014. So you'll have a year to continue to run and use the old style with the old permissions and licensing, and you can then move over that year to a different subscription for your production workloads. And then at August of next year, all the MSDN subscription would be transformed into the dev test only subscriptions. Okay, so with that, then we're going to dig into some more interesting scenarios, some specifics on the networking. I'm going to hand you over to Ganesh, who's an expert on our networking team.
Thank you. Hey everyone, my name is Ganesh Srinivasan. I'm a program manager in the Azure networking team. And I'm going to start off talking about hybrid offerings in Azure. I'm going to go through a couple of scenarios that we put together and give you an overview of what we have in terms of hybrid. Following which, I'll talk about a few scenarios that you could do in terms of real dev test cases. So it's like building an application using Visual Studio, trying them out on your developer machine, and actually doing a test against a SQL server that's hosted in Azure. We'll also do a test scenario where we'll do a load test on a SharePoint farm that's running in a virtual network in Azure. And that will tie the story really well. So let's get going. So hybrid means a lot of different things for a lot of different people. It means migrating data from the premises to the cloud. We have a lot of offerings around that. Or you want to build an application that's truly distributed, a pub-sub kind of a model works. In that case, we have Service Bus as a solution for doing that. But really, from a dev test perspective, it's about linking the infrastructure in your premises to your services that you want to run in the cloud. So that's where the last two solutions come together. We basically have Windows Azure Virtual Network as a solution that's part of our infrastructure services offering. We made it generally available earlier this year. And to that, we've actually added a new service called the Virtual Networks Point-to-Site solution, which is really new. We released it in preview about a month back, and we plan to make it generally available in the next few months. So I'm going to be spending the next few minutes talking about primarily the point-to-site solution that we have and how it complements all the investments we've made to make your life simpler for the dev test scenarios. So primarily speaking, virtual networks is a solution that we put together in Azure to be able to enable you to build a secure network that has a larger scope than a single cloud service. So it enables you to put a lot of services within the virtual network that can talk to one another. It has a lot of benefits in the sense that it offers you the ability to control the IP addresses, the private IP addresses of the virtual machines that you run in Azure. And it allows you to basically make sure that the IP addresses that are allowed for the virtual machine stay with the virtual machine for its entire lifetime. In addition to that, this is the ability that actually makes it possible for you to run a DNS server or a domain controller in Azure. And if you look at all the applications that people typically run, which could be SharePoint farms or any line of business application, Active Directory is usually the glue for all the applications, and because identity is essential for all applications. So essentially, to make any multi-tier application to work, you need a network that basically allows you to communicate within itself on a private address and has stable IP addresses for communication. And that's what virtual networks offer. In addition, we actually offer a managed gateway that allows you to connect back to your premises over an IPsec VPN solution. We supported standard Cisco and Juniper devices on the customer's premises side for connectivity. We were happy to announce the fact that we've added F5, Citrix, and WatchGuard to that series of devices, and we've made a lot of enhancements there. In addition to that, you can also run Windows Server 2012 as your site-to-site VPN solution. So you can actually have connectivity between your premises and the cloud without having to invest on any hardware device. All you need is a standard Windows Server 2012 machine that's at the edge of your network. You run a PowerShell commandlet on top of it, and we automatically configure it as a routing and remote access server and configure all the routes to be able to communicate with the virtual network in Azure. I will show you that in a little bit. Now, in addition to that, we've introduced this point-to-site solution because it simplifies the time it takes to basically set up connectivity and get going with Azure. So typically, if you were to rely on an IT administrator to hook you up with connectivity to the cloud and have a virtual network set up and get things going, it's going to take you weeks or even months. Probably.
Yes.
So we'll show you how to bypass that and get going in a matter of minutes. So we had a technology called Windows Azure Connect, which we are retiring. It offered machine-to-machine connectivity between any machine that's running in the cloud and between any machine on-prem using an IPv6 relay network. We are retiring that service, and in place of that service, we are announcing the support for this point-to-site connectivity. Now, when we designed this, we had a few goals. IT admins and people don't like the fact that you have to install any agents or any software to provide connectivity. So we did not want to do that. We decided to leverage the VPN service that's built into Windows. So every Windows machine has a built-in VPN client stack built into it. We are just we are going to give you a client policy that enables you to connect back to the cloud. The second thing is that most machines tend to be behind NATs and firewalls. You could be in your office behind a lot of firewalls, or you could be in a coffee shop or some other place where you really don't have a public IP address that's connected to the internet. So we had to come up with a way where you could actually, that's standards compliant, and that could actually traverse these NATs and firewalls. So we actually chose this protocol called SSTP, which is Secure Sockets Tunneling Protocol, which essentially establishes a tunnel over HTTP. It looks like HTTPS, so it looks like an SSL connection from your proxy's perspective, but it's actually a tunnel through which you actually transfer packets back and forth. So if you just have a VPN client running in your Windows machine, and you just dial into your virtual network, you have a bidirectional connection set up with your virtual network, and you can have complete IP-level connectivity between whatever you have deployed in a virtual network in Azure and your machine, be it your dev machine or your laptop. So this is how it typically looks. And the way we built it, you could have your point-to-site connectivity coexist with your site-to-site connectivity. So if you're building an application, let's say a SharePoint farm or any line of business application that has the need for you to talk to an on-prem domain controller, you could have the site-to-site connection established to have your virtual network talk to your premises using that link. You could run a read-only domain controller for making sure that you don't corrupt your domain controller in the cloud unnecessarily. And running it in Azure makes your life easy because the latency is going to be lower. And you could use the point-to-site connection to essentially connect directly from your dev machine or any machine back to your virtual network in Azure and do whatever you have to do. So the next few minutes, I'm going to be using this technology to establish a VPN connection from my laptop here to the virtual network that I've already set up in Azure. Before that, we'll set up one. We'll go through the process of setting up one. Then we'll connect to a virtual network that's already been set up there, do some dev and test exercises to see how it works. So I'm going to switch over to my laptop to show you a series of demos. Okay, Drew just gave you an overview of what the Windows Azure portal looks like and how you create virtual machines. I'm going to take it one step further and show you how to create a virtual network. I know when you talk about networks, it's sometimes complex for a developer to imagine. It's going to be a hard thing to do. It's not really that hard for you to set up a virtual network in Azure. We actually have a very user-friendly wizard through which you could just click through to create a virtual network. So just the way you created a virtual machine, we have a wizard in the portal that allows you to create a virtual network. There are several ways in which you can create a virtual network. We have a configuration file just like how you're used to CSDEF and CSCFG for compute, where we publish the schema, and you can actually author up a network configuration file and import the network configuration file into Azure. That would automatically populate all your networks and set it up in one shot. If you're not really into filling out XML schemas and setting things up that way, you can actually use the wizard, and the wizard will actually create the virtual network for you. So we can do a custom create, and it's going to ask you for a name for the network. And it will ask you to put it in an affinity group. Now, the reason we ask you to put it in an affinity group is that it actually pins it to a location, and it makes sure whatever services you deploy into that affinity group actually lands into that virtual network and are close to one another, and the latency between them is actually contained. So I'm going to create an affinity group, and this affinity group can be in any location. So I'm going to pick East US. And if you have multiple subscriptions, you can pick the subscription into which that network actually goes into. So there are a lot of things that you can set up. The first thing is the fact that when you set up a network, if you want virtual machines to talk to one another, you typically want some sort of a name resolution service so that you can refer to them by name rather than use IP addresses to refer to them. Azure actually provides its own DNS service built in. There are two DNS services, in fact. One that's for public name resolution. That's the name that you give for your cloud service. And we also run a multi-tenant cloud service internally where all virtual machines that are part of the same service actually can use that service. When you create a virtual machine, we automatically register the virtual machine in that. So if you create multiple virtual machines in the same cloud service, you can just refer to them by host name, and they'll know whom you're talking to. Now, in addition to that, if you're setting up scenarios where you're using a domain controller that's either on-prem or you're setting up a domain controller in Azure, you can actually give them the IP address of a custom domain controller that you've configured. This could be either running in Azure or running in on-prem. All you're doing is giving us an IP address. So every time we bring up a virtual machine or a service, we populate the DNS server's IP address through DHCP to those virtual machines. So you can choose to give up to 9 DNS servers for every virtual network, or choose to leave it, in which case we automatically default to the Azure provided DNS service. And we used to have a problem. We used to ask you to provide us with the DNS server at this point, and you were locked onto it. Now, we've made a lot of changes in the platform, so you can actually go back after you create your virtual machine, set up your virtual network, set up your virtual machine as your DNS server, and go back and update the properties of the virtual network. So that makes your life extremely simple. So in terms of connectivity, I have two options. I can do point-to-site or site-to-site. Since we are going to be focused on dev test scenarios, I'm going to show you how to create a point-to-site virtual network. So all you do is select on this option. If you select both these options, it's going to diagrammatically show what it's building. But we are not going to do a site-to-site connection today. So once you select that, now what you're going to do is we're going to create a virtual network in Azure. We're going to assign it some IP addresses, and we're actually going to connect to it from about 200. You can connect to it from about 250 virtual machines or laptops or any machines that are roaming anywhere. Now, for us to be able to route packets from these machines to the virtual network in Azure, we need an IP address. So we are going to provide this wizard with two IP address ranges, one for your virtual network and the other for your roaming VPN clients. We'll start by providing the IP addresses for the roaming VPN clients first, and then we will provide IP addresses for the virtual network. So in the next page, it's going to ask me to provide IP addresses for my roaming VPN clients. And this could be any private IP address that you want to use. So let's say I'm in this building, and this building has a 10.IP address range. If you go do your IP config in any of your laptops, you'd see a 10.IP address. So I may want to choose a 172 or a 192.IP address for my roaming VPN clients. So I just picked an IP address range. I can have up to 250 VPN clients connecting to my virtual network at any given point in time. So I'm going to pick a /24 subnet in CIDR notation, which means I can have up to 256 IP addresses there. I will then have to specify IP addresses for my virtual network. Now this, I could choose any private IP address range again. I'm going to use the entire 10 dot space for my virtual network. And within my virtual network, if I want to partition various tiers and put them in different subnets, I can create multiple subnets. So let's say I'm building an application where I'm going to have a front-end subnet, and I'm going to have up to about 200 virtual machines in that subnet. I can give it a /24 subnet. I can add as many subnets as I want, as long as all these subnets that I configure are disjoint from one another, and they fit within the virtual network address space. Sorry.
You forgot something, Ganesh.
That should have woken anyone up who's about to go to sleep, so thanks. So the one more thing that you have to do is if you need connectivity, we actually create a virtual network gateway. The gateway is actually dedicated for you, so we actually create 2 RRAS servers in your virtual network and run them in active passive mode for high availability. But we have to run it within your virtual network so that we can route packets to it. So we ask you to create a gateway subnet within your virtual network so that we can place those gateway virtual machines within your virtual network. So that's what I did. I created a small /29 subnet with 8 IP addresses in it so that I can place my gateways within that subnet. And that's all I have to do. My virtual network is actually in the process of being created, and within about a minute, we'll give you confirmation about the fact that that virtual network is actually created. So once the virtual network is created, you actually have to go into your virtual network and start your virtual network gateway. This is an operation that triggers us to deploy the remote access servers into your gateway subnet. So we're going to take about 5 to 6 minutes to deploy a gateway into your virtual network. And we are actually billing for the virtual network gateway. We charge you 5 cents per compute hour for your virtual network gateway. So once you have the gateway started, from the time you start your gateway till you stop your gateway, we will charge you for the compute hours on your gateway. But we don't charge you for creating the virtual network. So the virtual network has been successfully created, and I can create my gateway by just selecting Create Gateway. So in the interest of time, I'm going to switch to another virtual network that I've created, and we'll continue the demo from there. So I've moved to a new virtual network that's going to populate here. That virtual network has both site-to-site connectivity as well as point-to-site connectivity. I have this virtual network connected to my premises, my office. I have a routing and remote access server running there to which I've connected. So I have an IPsec tunnel connecting to it. I basically had a physical machine configured in my office, put it on a DTAP port which is directly connected to the internet, and went ahead, downloaded a VPN configuration script. So if you have any of these standard devices, you can actually pick the OS family, and when you select it, we give you the VPN script. This is actually a PowerShell script. You could save it as a PS1 file, enter the VIP and certain parameters that we ask you to fill in here, and run it on PowerShell in admin, with admin credentials in your machine that you want to configure as your routing and remote access server. It will reboot once, and once it's rebooted, it's actually your gateway, and the tunnels are actually automatically set up from that point on. So it's as easy as running this PowerShell script to get your site-to-site connectivity going. Now, in terms of point-to-site connectivity, there's one challenge, which is we've documented it, which is the fact that you need to create a pair of certificates for us to be able to authenticate you so that we know it's actually you who's connecting to us. So you have to generate a client root certificate and share the public key part of the certificate with us so that we can do a mutual authentication with you. So you give us that, and for every VPN client that you want, you can choose to create a child certificate from the root certificate. So you can create multiple child certificates and hand it to every person who wants to have connectivity. So you upload the root certificate into our portal, and once you've uploaded the root certificate into the portal, you're now ready to actually download a VPN client. We actually generate a VPN client on the fly for you. So all I have to do is download the VPN client for the hardware configuration I have. We support standard VPN clients for Windows Server 2008, Windows 7, Windows 8, and Windows Server 2012. You can just download the VPN client and run it in your machine after we installed the certificate. So I've installed the VPN client, and that's it. It's as simple as that. This is not code that we've installed in your machine. It's just a configuration package that tells us that we have to use the certificate and we have to connect to the gateway that's running in the cloud. So it doesn't actually deploy any code into you, so you don't have to go look for updates or patches to get that going. You're going to get the standard Windows patches, and that's all. That will take care of this. So once you've done that, it's going to appear in the list of VPN connections that you've configured. If you look at it to your left, you can see the fact that the virtual network is called TechEd BRK Lite, and you can actually see a VPN connection with the same name. So I'm going to connect to it. It's going to pop up a standard VPN client dialog, and I hit connect. And I'm right now connected to, this machine is right now connected to the virtual network in Azure, and I don't have to do anything. So just to show you that it is connected, you can see that it's got an IP address. It's a private IP address for this forwarding VPN tunnel interface that's been created in that machine. So any packet that I send to any machine that's in the virtual network, so if you look at this pane here, I've got a bunch of virtual machines that are actually deployed into the virtual network. So I actually have a SharePoint farm, a single instance SharePoint farm with 3 virtual machines running that I'm going to use for one of my demos today. And I also have a PaaS service that's running there. And you can see the private IP address of all the virtual machines there. So I could ping, or I could connect to the virtual machines. And the response is instantaneous. So I have full IP level connectivity to that virtual machine that's running there. So setting up a network in Azure is as simple as clicking through a bunch of buttons here and downloading a VPN client. Now, when you do this, you can connect to the virtual machine through the private network, so you don't have to really expose the virtual machines to the public internet. So let's go to this virtual machines that we have, and let's delete the public endpoint so you know for a fact that that virtual machine is actually not exposed to the internet. So in this particular case, I have a SQL server that I'm going to be using for one of my demonstrations, and it's purely a backend database. Today, for the sake of simplicity, we by default, when we create a virtual machine, create an endpoint for you to be able to remote desktop into the virtual machine, and we've also enabled WinRM, so you can actually do remote PowerShell into the virtual machine. I don't need them anymore because I have backend connectivity to the virtual machine. So I can just go ahead and delete the endpoints from the public internet. So this virtual machine is not exposed to the internet. There is no way to connect to this virtual machine from the public internet, so it's extremely secure. So now let's use this database. I'm going to delete the endpoints, but while the delete operation happens, let's look at building an application and seeing what we can do. Now, this is the same database that I pre-configured in my Visual Studio pane. So I gave it the private IP address, and I can actually enumerate it because I have backend connectivity through my VPN client. I can look at all the tables that I have, and I have a bunch of tables that I created just for the sake of the demo. So we have basically a list of items that we could go through, and we could actually view the content of the So it's going to take a couple of minutes for you to be able to query the database and give us all the data that's actually stored in the database. Now, we are going to right now do the dev part of the exercise, where we are going to create a web application that uses this database. Now, we are going to develop the application as a web application on this machine, run it on IIS Express in my local box, test it out, then see if it is worthy of publishing. Instead of publishing it into an IIS server that's running in Azure, it may be worthwhile trying to run it as a PaaS instance in Azure that's talking to a SQL Server database. Let's try all that out, and then we can then publish this application as a proper web role running in Azure that talks to the backend database. We'll go through all the steps. So for the sake of the demo, I actually pre-created a project that has web content in it. So if you look at the web.config, it's just a simple application that's going to show you a portal that's going to allow you to add, edit, and delete items from a list. But if you look at the connection string here, I'm using a data source of a SQL server, and I'm using the private IP address of the SQL server when the public IP address of the SQL server is a 137 IP address. We deleted all the endpoints on the SQL server, so it's not exposed to the internet anymore. So the only way to connect to it is using the private IP address here. So I've specified the IP address of the SQL server in the connection string for my application. Now, I'm going to make the application run as a local application. Okay, I've set this up as a startup project, and I'm going to debug it first. So when I actually started it right now, it's actually going to start up an instance of IIS Express, and it's going to run this on the IIS Express that's running locally in the box. Now, this front-end application is connecting to the database that's connected in the cloud, and it's going to pull up stuff. So I can click on the items table that we just pulled up using Visual Studio SQL Explorer, and it's going to populate all the values. So you can see all the items there. Let's say we have this random item called 2 that I want to delete. I can delete this item using this test application, which is going to be reflected in the database SQL server that we actually have there. So the item is gone right now from the table because it's actually talking to the SQL Server database, and the update happened. So we know for a fact that the application actually locally works as a web application. Now, if I wanted to make this a web application, you start it as a web project, and in addition to actually having this code ready, you will have to specify a configuration for your virtual machines to be run as a PaaS service. So if you click on the service, it actually creates a configuration file and a definition file. So the definition file tells you what you have to do. Since it's a web service, I want to expose it to the internet. I want to have a web, I want to call it a web, and I want to have an endpoint to it that's going to open up port 80 to my web service, and it's automatically going to be load balanced if I throw multiple instances at it. So I define all that in my service definition file. If you're used to publishing PaaS applications in Azure, it's a straightforward concept. But if not, Visual Studio actually has a wizard that takes you through this to create these configurations. So you can actually specify any other additional configuration that you need if you wanted to put in here. So the service configuration just builds a template for that, and the service definition provides the template, and the service configuration tells you what you have to do with the template. So you could actually specify the number of instances you want to be deployed, and in this case, I'm going to have 4 instances of my web front end when I deploy it into production. And there's another section here where I'm going to put this PaaS service into my virtual network. So I've got to specify the fact that this service has to go into a virtual network. So I have to specify the virtual network name, and I'll have to place each role in a subnet or a collection of subnets. So specify each role's name and specify the subnet into which they have to be deployed into. And once I specify these parameters, I'm ready to actually deploy this service into production as a PaaS service. But before we do that, let's try to emulate and see what actually happens when we run this application as a web role in emulation mode. So if I was to debug this application right now, it's actually going to open up the Windows Azure emulator. I guess I made a mistake in not opening this up in the elevated command prompt. So it's saying it cannot. But let me quickly do that. So we have it set up, and it's actually going to start up the Windows Azure emulator, and it's going to run a single instance because for the emulation I set it as a single instance, and you're actually going to see the same page through which you can edit. Even when you're using an emulator to emulate it as a web role, you have full connectivity to that backend database that you're running in Azure, and you could actually change any database or any properties of it, and it's pretty seamless. So we had a few questions in the past asking, okay, if you can do this from your dev machine to the internet, I want to do the opposite of it. I want to run and test applications that are in the cloud, but I want to use on-prem resources. Let's say my SQL database is on-prem, just the opposite of this scenario. You can do that, but in such a case, we'd recommend you to use the site-to-site capability rather than the point-to-site capability, because with the point-to-site capability, you're connecting from a VPN client, and every time you connect and disconnect, the IP address assigned for your virtual machine interface that's using the forwarding interface in your laptop typically changes. So you don't want to be in this kind of an environment where your IP address changes if you're trying to build an application. So in the case you're taking a dependency of using something on premises, we'd recommend you to use the site-to-site VPN solution. So now we know for a fact that we are running in emulation mode because I have the emulator running, and we have the web and worker roles. We can see the fact that the web role is actually running properly on the emulator and is able to connect to the backend database. So let's now look at how we publish this. So we've got the fact that it runs as a web application locally. You can publish it to IIS and have it run on a virtual machine, or you can emulate it in PaaS. Now let's publish this as a cloud service into Windows Azure. So and it's pretty straightforward. So you could go to your subscription, once you've provided the credentials, you can pick the subscription into which you want it deployed. It will automatically enumerate all the cloud services that you want to deploy this into, you could pick the cloud service that you want to deploy it into. In this case, I created an empty container for this cloud service, and it allows you to specify which slot you want to deploy it into. Since I'm going to be testing it, I'm going to be putting it in the staging slot, and it publishes this service. So it's as easy as that. So once you click through it, it's actually going to upload the package that you've put together into the Azure storage account that you have in that region, and then it's actually going to push that package into your virtual machines that are spun up for you as a PaaS service. So when it's fully running, you'll actually have 4 web role instances that actually share the front-end load, that are load balanced on port 80, that all talk to a back-end database that's hosted in the same virtual network. Now, before we started this demo, just to save time, I actually deployed the same package into the production slot of that same cloud service that we looked at. And we have 2 slots in the case of PaaS. One is production and one is staging. You could actually use that for rolling updates. So you could actually deploy version N+1 into your staging slot, have it fully tested, and do what is called a whip swap. So when you do a whip swap, we actually map the public IP address of your service to the production slot, or the slot that you want as production, and move whatever was in your production slot into your staging slot. So that way, you can continuously have version N running in your production environment and have N+1 in your staging slot, test it out, and then swap them appropriately. So for the sake of the demo, I already had the same application running in the production slot. So let's take a look at it. So it's actually a cloud service called TechEd Dev. And if you take a look at the dashboard, you'll see the fact that I have 2 small instances running in it. And since I've defined port 80 to it, it's accessible from the public internet, and I've closed all other ports to it. So it's going to take a few seconds, and it's taking a little bit of time in this case because I've connected to the point-to-site connection, and I have a DNS server running there. It's using the DNS server for name resolution rather than using the ISP's DNS server. But here it is. It's now a PaaS application that's running in Azure that's actually using a SQL Server database that's running as a virtual machine. So what I wanted to show with this is the fact that you can actually mix and match IaaS virtual machines and platform as a service virtual machines to put together an application, a multi-tier application, where you're using a SQL Server database as your backend. And if you have a lot of data, you wanted to use SQL HA or any other technology to use for your database, you can do that. And you can still start moving your front ends or your stateless tiers into PaaS services so that they are extremely scalable. Now, in this case, I have 2 small instances that I'm running as my front end. Let's say the service became a big hit and I had a lot of load. All I had to do was actually dial up the number of instances that I throw at this service and save it. This is automatically going to spin 9 more instances of the front end code, run it, automatically load balance it, and enhance the capacity of your service. So it's as easy as that if you were to mix and match PaaS and IaaS and get your service up and running. So let's move over now to actually look at what we can do in terms of test. So for that, what I'd done before we started was actually deploy a SharePoint farm in Windows Azure. Now, we had a talk earlier this morning where we talked about how you actually set up a SharePoint farm. We have PowerShell scripts that we published in GitHub that you can go and access. There are 2 configurations by default that we support. One is a single instance case where you have single instance front ends, a single instance SQL Server as your database, and a single instance domain controller. We also have a highly available configuration that deploys about 9 to 10 virtual machines that makes every tier highly available. So all you have to do is customize a script, run the PowerShell script, and in about a couple of hours, you have a huge SharePoint farm. So in this account that you're seeing, I actually have 3 SharePoint farms, 2 highly available SharePoint farm, and 1 single instance SharePoint farm. And for the sake of this demo, we're going to use the single instance SharePoint farm. Now, I set up a SharePoint farm, and I want to know if it actually performs. So I want to do a load test on it. So we are actually going to do a load test on this SharePoint farm. So we're going to close this project. And we're going to create a new project for load testing. So if you attended the keynote and you had attended a few other sessions on dev test, Visual Studio actually has a new service that allows you to use TFS Online to actually launch all these massive load tests. We're going to show a smaller scale version of this load test for the sake of this demo. I'm going to create a simple load test project where I'm going to actually connect to the SharePoint farm from both the internet as well as the private channel. And I'm going to actually generate some spurious load. Then I'm going to simulate the same load being hit by about 250 users. So for me to do that, all I have to do is actually record a simple test. And the simple test could be as easy as connecting to the SharePoint farm. And what this tool does is it actually records every step that I take, and it will actually play it back at high speed with simulating multiple users. So the SharePoint page is up. Now let's say I wanted to change some text in this, and I wanted to basically personalize this web page. And I go back to this page. I actually wanted to change the site permissions for someone. I could do that. I could add grant permissions or do anything just to show you that it's actually recording. I'm clicking through stuff. Then I stop it. So these are all the steps that we just performed that's saved as your test. Now I'm going to provide it with credentials so that it can be repeated multiple times. And I could actually record multiple sets of tests. So if I wanted to test just my front end, I could create a dedicated test for that. I could have another one just for updating contents and refreshing pages as another test. And I could actually run them in collection. So now that we've composed the test, and I've provided credentials for it, I can actually run this test and show the fact that it's actually running. Every step is running, and I'm able to connect to it. Now I can actually create a load test into it and actually use this to simulate load on that. So I'm going to create a simple load test where I'm going to start with 10 users and repeat the same operation in steps of 10 till I hit 200 users. I'm actually going to add just this test to show you the fact that you can do that. You can simulate various environments. You can add lossy networks or simulate just a LAN kind of an environment. In this case, I'm going to simulate a LAN kind of an environment. I can also simulate different kinds of browsers. I could add a mobile browser in case I wanted it. So I'm going to add Safari to it. And I could also add machines from which I can get performance counters. So if I added this, it's going to ask me what all counters I wanted. Let's say I pick these. It's automatically going to grab all the counters from me, from all these machines. Then I can specify the time for which I have to run this test. And that's it. My test has been defined, and I'm ready to run the test. So you can see that now I've actually not connected to the public internet at all. I've defined a load test connecting to the SharePoint, logging into various pages. I could do that both through the public internet as well as through the private channel, and I've launched the load test. So this test will actually log statistics every few seconds so that you have multiple data points that you can see. It will show you page response times and whatever other metrics that you've added, and it will actually plot a nice graph for you as it goes through it. And once you're done, it's going to give you a beautiful report showing all the statistics that you actually wanted to see. So setting up this connectivity and gathering all these statistics is as easy as whatever you used to doing in your premises. So if you had the same SharePoint in your offices as in your dev box or in your test labs, the experience is identical. So you'd connect to it using a private IP address, not worry about the fact that it's exposed to the internet, and do whatever kind of tests you want on it, and then launch it for production. So doing dev and test scenarios are extremely easy in Windows Azure. Now let's get back to slides. So I showed you the fact that you can actually have a SharePoint farm deployed in Azure. Till last weekend, I had no idea of how to deploy a SharePoint farm. I had no idea of actually how to use Visual Studio. I'm not a developer. But I was able to set all these things up in actually a single day. So I ran this PowerShell script. I downloaded it, followed the instructions, and it was easy to set up a SharePoint form. And Visual Studio made my life extremely easy. I didn't have to do much to figure out how to do a load test in SharePoint. So I urge you all to actually try it out and do all these things. It's extremely easy. In addition, before I get to summary, we actually have a few more videos that our incubation team put together to highlight these dev test scenarios. So I urge you to view them, download the presentation, and view these videos. They give you a better idea of what all is possible with dev test in this platform. So let's go back to summarizing the platform. Drew talked about the fact that we have per minute billing, and that's going to actually make a big impact when you're doing dev test kind of scenarios where you're not charged for the full hour. So it's going to help you save a lot of money, especially when you have $50 or $100 as a quota for your MSDN subscriptions. The MSDN offer is going to make your life extremely easy. You're going to pay 6 cents an hour for a SQL server, for which you typically pay $2 an hour. So it's going to be cost effective for you to do your dev test in our platform rather than run them as virtual machines. Basically, if you stop your instance, we don't bill you for it at all. So that's another set of savings that we help you save money there. So it's cost efficient for you to do dev test in our platform. We've actually offered you many ways to connect to the platform through the back end rather than coming through the public internet. So you have a site-to-site option where you can connect to your networks in Azure from your premises and use all your on-prem resources. And we have another point-to-site solution that you can use to connect from any developer machine to your virtual networks in Azure without having to worry about your IT admin providing you with access and connectivity. So overall, we've tried to make a lot of efforts to make this an ideal platform for you to do your dev test work on. Now, this is just a start for us. You'll see a lot more features and capabilities coming in our platforms that make your life easier. And we also are working hard to integrate all our tools together so that any Microsoft products and tools work better together in our platform. So with that, we have a lot of sessions that are happening this TechEd, all centered around Azure. And I'd urge you to take a look at some of the sessions here. They'll give you a better idea of what we've done in partnership with a lot of teams. So the talk before this was a talk on SQL high availability with Windows Azure. We had one on SharePoint and Windows Azure. We had a talk on hybrid, and we have a lot of sessions talking about various topics. In addition, we also have a session that talks about the customer experiences and what we've learned in working with a lot of customers and what a lot of customers have done in doing their dev test and other scenarios in Windows Azure. So I urge you all to attend these sessions and learn more about what our platform has to offer. Zach, if you're open for questions.
Especially the one with customers, that's a great one. The infrastructure service recently came out of the preview state, and there's a lot of customers that use this really hard during preview. And in fact, a lot of customers, when we said don't go into production, they said, I really like this, I'm going to go ahead and do it. So these guys can actually, even though it's a fairly new service, you can get a lot of really great insight from these customers, both from dev test usage, because some of these customers are focusing on that way, but also production usage. And so that session on Thursday can be really, really useful. With that, we'll open it up. I think I had one question that I wanted to hit, and then we'll hit this. Maybe that was who was calling. There's a question online before about OS versions, specifically client OS versions, and I forgot to talk about that earlier. The server versions are available in Windows Azure. Today, we don't have the ability to run client versions, and that's some of the licensing that's associated with the client versions. They're not available for use in any public cloud environments today where the machine is not dedicated to you. That's something to keep an eye on, something we're working on, moving more and more of our stuff to the cloud, but it is a situation where we are right now just based on licensing. With that, we'll open up to questions. Okay.
So you can connect your virtual network on premises, your network on premises to the virtual network in Azure. So they look and feel as though they're in the same network. You have IP-level connectivity between them, but they're not on the same hypervisor.
So I can run my client.
Yes. Yes. Yes.
Correct. Question here?
How do you do group development? Productive team, like a development, 5 people on a team, they all use TechEd,
we enable connectivity for you. So you have the same VPN client on 5 different machines. Everyone can connect to the same resources in the cloud.
So often what
Yes.
happens in the cloud, the way that the MSDN is structured is everybody who is using if you're using MSDN benefit, everybody has to have an MSDN subscription. But they can all then share that account. Now, we don't have the ability right now to pool resources. So if you've got 5 Ultimate that you have, like $500 or $750, that's not there yet, but you can use the same account, share those accounts. The key thing is everybody using that needs to be an MSDN subscriber for that individual. Yeah. Also, we do have the Ask the Experts downstairs, so we'll...
Starting in about 10-15 minutes,
Done.
you can find us there if you have any questions.
Okay.
Thank you.
Thank you, guys.